All right, Sean McClendon from MathSwap Tutoring here. Were you getting ready to take the SAT, but then you found out that there was trigonometry on there and it scared you? Maybe you have not taken trigonometry before, or maybe you're in trigonometry and you haven't, actually started to take it yet, or whatever. Or it just sounds scary. Look, I promise you, you have nothing to be afraid of. When you watch this video, you'll understand what I mean. So, yes, there is trigonometry on the SAT math section, but I don't want you to be concerned about it because it's not that bad. As a matter of fact, you have seen most of it if you've taken geometry already. Okay. And even if you haven't even taken geometry already, it's not that hard to understand. I promise you. What I'm about to show you is the extent to which trigonometry is on the SAT, and it just scratches the surface of trig. Okay, it's some of like the very, very fundamental aspects of trig, again, that you've already seen on in geometry. Okay, so don't get scared. Watch this. All right, y'all. So let's talk about trigonometry on the SAT so you can understand what they really are putting on there rather than being scared about the trig on the SAT. Now, you have what's called right triangle trigonometry on the SAT. I just put right triangle trig for short. And then you also have radians. You have to understand how radians work. So let's talk a little bit about right triangle trigonometry, which you touched on in high school geometry. So you see this right triangle. We know it's right because this angle here is 90 degrees. That means it's right triangle. Then you have it labeled A, B, C. So you have what's called the trigonometric ratios, which you've heard of as sine, cosine, and tangent. Okay, sorry, that's a little sloppy there. Those are the trigonometric ratios. What they are ratios of the sides of a right triangle. Now, depending on what ratio you're looking to use, determines what sides of the triangle you use in your ratios. So say for example, we're taking this angle right here, angle A, and we want to find the sine of angle A. So that would be written as sine of A, okay? And so that is going to be equal to, and let's go ahead and put some stuff here. So sine is going to be opposite over hypotenuse. So in other words, so this is the hypotenuse, okay? It's always the side opposite the right angle. The sine of an angle is a ratio of the side length opposite the angle over the hypotenuse of the triangle. Okay. So in this case, the sine of angle A is going to be a ratio of the side opposite angle A, which is line BC, over the hypotenuse, which in this case is AC. Okay. Now, cosine is going to be the adjacent over hypotenuse. In other words, the cosine of an angle is a ratio of the side length adjacent to the angle, which is right beside it, over the hypotenuse length. Okay. So the sine, I'm sorry, we just did sine. The cosine of angle A is going to be a ratio of the side adjacent to that angle, which is side AB, over the hypotenuse, which is AC. Okay. And then tangent of an angle is opposite over adjacent. In other words, the tangent of an angle is a ratio of the side length opposite the angle to the side length adjacent to the angle. So for this, it would be the tangent of angle A will be equal to the opposite side, which is BC, over the adjacent side, which is AB. Okay. And so that's the extent of the right triangle trigonometry, honestly, that you're going to really need to know and understand. Okay. So that's it. That's it. That's it. And you've seen this in geometry. Now, let's go over to radians. So all you really need to understand is this. First of all, how many degrees are in a circle? There are 360 degrees in a circle. If you start here and you come all the way around, you traveled 360 degrees. Now, what you have to understand is 360 degrees, um, that's when you're measuring the um, angle measure of a circle in degrees. Now, you can also measure um, angles with radians, okay? And so that's going to be um, in radians, when you start here and you go around, that measures 2 pi radians. Rad. You probably seen that on your calculator. All right. So now, a lot of times, what you're going to need to do is to convert from degrees to radians. Okay. And so you might have to use the ratio 360 degrees over 2 pi radians. For example, if somebody was like pi over 2 radians is how many degrees. So you would multiply pi over 2 radians times 360 degrees for every 2 pi radians, and then you would get that. Okay. So that's an example of how you might use that. So common angle measures. So say, for example, you have 0 degrees, that's going to be 0 radians. Then you have 90 degrees, which would be up here. That's going to be pi over 2 radians. Now you can also just kind of calculate these using that conversion factor. 180 degrees is going to be pi radians. Then you have 270 degrees. That's going to be 3 pi over 2 radians. Then you have 360 degrees, which is going to be 2 pi radians. Okay. Now you can also kind of like, sometimes 30 degrees will be important, 60 degrees will be important to remember, and others, but these are going to be the main ones. But if you remember that 360 degrees is the same as 2 pi radians, and remember, you can use that to convert from degrees to radians or vice versa if need be. Let me talk about one more thing here. Okay. Okay. So let's see. Now, if we want to, oh, I'll go this way. So say, for example, if you consider, let's consider our right triangle again. Remember the fact that sine um, and cosine are complementary. And if you remember, that means that they sum up to 90 degrees. Okay. So let's kind of label this like the other one I had. So therefore, think about this. Sine of angle A is equal to cosine of 90 minus A. Okay. So keep that in mind. Now, how do I know that? Think about it this way. So the sine of angle A, let's see, the sine of angle A is going to be equal to BC over AC, right? Okay, now, whatever angle A is, we know that angle A and angle C are going to sum up to 90 degrees. Okay. So think about this. 90 minus A is basically cosine C. Okay, because this angle, this angle, are going to add up to 90 degrees because the total of the sum of angle measures in the triangle is 180. So these should sum up to 90 degrees. And if I'm taking, well, if you have the sine of A and we're saying that's equal to cosine of 90 minus A, 90 degrees minus A is going to give us C. So that's cosine C. Okay. And what is cosine C? It's going to be the adjacent side over hypotenuse. Cosine of C is equal to BC over AC. You see that? So keep that in mind. So let's go the other way. So what about if we were trying to find the cosine of A? How does that relate to sine? Okay. So the cosine of A, we know it's going to be equal to AB over AC, adjacent over hypotenuse. So the sine of what is going to be that? So the sine of C is also going to be AB over AC. Sorry. So again, this is going to be equal to the sine of 90 minus A. Okay, because again, 90 degrees minus A is going to give us that, and then that's going to give us AB over AC. So when we say that sine and cosine are complementary, this is really what that amounts to. And this might come in handy for you on the SAT as well. Okay, to remember that they're complementary. All right, so hopefully that's helpful. Let me know if it is. If you need any other clarification, comment below the video. Have a great day. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with MathSwap Tutoring on YouTube. Have a good one.